Jupiter is the fifth planet from the Sun and the largest in the solar system. It is a gas giant with a mass more than 2.5 times that of all the other planets in the solar system combined, and slightly less than 1/1000th the mass of the Sun. Jupiter orbits the Sun at a distance of 778.5 GM with an orbital period of 11.86 years. Jupiter is the third brightest natural object in the Earth's night sky after the Moon and Venus, and it has been observed since prehistoric times. It was named after Jupiter, the chief deity of ancient Roman religion. Jupiter was the first planet to form, and its inward migration during the primordial solar system impacted much of the formation history of the other planets. Jupiter is primarily composed of hydrogen, 90% by volume, followed by helium, which makes up 1/4 of its mass and 1/10 of its volume. The ongoing contraction of Jupiter's interior generates more heat than the planet receives from the Sun. Its internal structure is believed to comprise an outer mantle of liquid metallic hydrogen and a diffuse inner core of denser material. Because of its rapid rotation rate of 1 rotation per 10 hours, Jupiter's shape is an oblate spheroid. It has a slight but noticeable bulge around the equator. The outer atmosphere is divided into a series of latitudinal bands, with turbulence and storms along their interacting boundaries. The most obvious result of this is the Great Red Spot, a giant storm which has been observed since 1831 and possibly earlier. Jupiter is surrounded by a faint planetary ring system and has a powerful magnetosphere, the second largest contiguous structure in the solar system, after the heliosphere. Jupiter forms a system of 95 known moons and probably many more, including the 4 large moons discovered by Galileo Galilei in 1610, Io, Europa, Ganymede, and Callisto. Ganymede, the largest of the 4, is larger than the planet Mercury. Callisto is the second largest. Io and Europa are approximately the size of Earth's moon. Since 1973, Jupiter has been visited by 9 robotic probes, 7 flybys and 2 dedicated orbiters, with 1 more en route and 1 awaiting launch. In both the ancient Greek and Roman civilizations, Jupiter was named after the chief god of the divine pantheon, Zeus to the Greeks and Jupiter to the Romans. The International Astronomical Union formally adopted the name Jupiter for the planet in 1976 and has since named its newly discovered satellites for the god's lovers, favorites, and descendants. The planetary symbol for Jupiter descends from a Greek zeta with a horizontal stroke as an abbreviation for Zeus. In Latin, Iovis is the genitive case of Iopater, that is Jupiter. It is associated with the etymology of Zeus. The English equivalent, Jove, is only known to have come into use as a poetic name for the planet around the 14th century. Jovian is the adjectival form of Jupiter. The older adjectival form, jovial, employed by astrologers in the Middle Ages, has come to mean happy or merry, moods ascribed to Jupiter's influence in astrology. The original Greek deity Zeus supplies the root Zeno, which is used to form some Jupiter-related words. Jupiter is believed to be the oldest planet in the solar system. Current models of solar system formation suggest that Jupiter formed at or beyond the snow line, a distance from the early sun where the temperature was sufficiently cold for volatiles such as water to condense into solids. The planet began as a solid core, which then accumulated its gaseous atmosphere. As a consequence, the planet must have formed before the solar nebula was fully dispersed. During its formation, Jupiter's mass gradually increased until it had 20 times the mass of the Earth, approximately half of which was made up of silicates, ices, and other heavy element constituents. When the proto-Jupiter grew larger than 50 Earth masses, it created a gap in the solar nebula. Thereafter, the growing planet reached its final mass in 3-4 million years. Jupiter's mass is 318 times that of Earth, 2.5 times that of all the other planets in the solar system combined. It is so massive that its barycenter with the Sun lies above the Sun's surface at 1.068 solar radii from the Sun's center. 6 Jupiter's radius is about 1/10 the radius of the Sun, and its mass is 1,000th the mass of the Sun, as the densities of the two bodies are similar. A Jupiter mass is often used as a unit to describe masses of other objects, particularly extrasolar planets and brown dwarfs. For example, the extrasolar planet HD 209458b has a mass of 0.69 mj, while the brown dwarf Gliese 229b has a mass of 60.4 mj. Theoretical models indicate that if Jupiter had over 40% more mass, the interior would be so compressed that its volume would decrease despite the increasing amount of matter. For smaller changes in its mass, the radius would not change appreciably. As a result, Jupiter is thought to have about as large a diameter as a planet of its composition and evolutionary history can achieve. The process of further shrinkage with increasing mass would continue until appreciable stellar ignition was achieved. Although Jupiter would need to be about 75 times more massive to fuse hydrogen and become a star, its diameter is sufficient as the smallest red dwarf may be only slightly larger in radius than Saturn. Jupiter radiates more heat than it receives through solar radiation, due to the Kelvin-Helmholtz mechanism within its contracting interior. This process causes Jupiter to shrink by about at the time of its formation. Jupiter was hotter and was about twice its current diameter. Jupiter is a massive ball of gas. Its clouds are composed of ammonia and water vapor drifting in an atmosphere of hydrogen and helium. The particular cloud chemistries are likely the magic behind the planet's vibrant colors, but the exact reasons for Jupiter's painted appearance remains unknown. Below the gassy upper layers, the pressure and temperature increase so much that atoms of hydrogen eventually compress into a liquid. Pressures climb so high that the hydrogen loses its electrons, and the soupy mess can host an electrical charge, just like metal. The planet's fast spin on its axis means that one Jupiter day lasts less than 10 Earth hours, and it sparks electrical currents that may drive the planet's intense and massive magnetic field, which is 16 to 54 times as powerful as Earth's. Multitude of moons, Jupiter is the second brightest planet in the night sky, after Venus, which allowed early astronomers to spot and study the massive planet hundreds of years ago. In January 1610, astronomer Galileo Galilei spotted what he thought were 4 small stars tagging along with Jupiter. These pinpricks of light are actually Jupiter's 4 largest moons, now known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Many of these celestial orbs are as remarkable as Jupiter itself. The largest moon in the solar system, Ganymede is also the only moon known to have its own magnetic field. Volcanoes rage on Io's surface, earning it the title of the solar system's most volcanically active body. And scientists believe Europa sports a deep, vast ocean beneath its icy crust, making it a top candidate in the hunt for alien life. But these are not the planet's only celestial tag-alongs. Jupiter has dozens more, and there may still be more to find. In 2003 alone, astronomers identified 23 new moons. And in June of 2018, researchers discovered 12 more Jovian moons that wander in oddball paths around the giant world. Since Galileo first laid telescope-enhanced eyes on Jupiter, scientists have continued to study the curious world from both the ground and the sky. In 1979, NASA's Voyager 1 and 2 spacecraft zipped by the gas giant, taking tens of thousands of pictures as they passed by. Among the surprises from these missions, the data revealed that giant Jupiter sports thin, dusty rings. And when NASA's Juno spacecraft began orbiting Jupiter in 2016, it quickly started sending back breathtaking images. The stunning pictures revealed that the planet is even more wild than we once thought. Juno returned some of the first detailed looks at the planet's poles, which revealed cyclone swarms gyrating on its surface with roots that likely extend deep below the upper bands of clouds. Though Jupiter has been so intensely examined, many mysteries remain. One enduring question is what drives Jupiter's great red spot, and what will happen to it in the future. Then there's the question of what actually lies at Jupiter's core. Magnetic field data from the Juno spacecraft suggests that the planet's core is surprisingly large and seems to be made of a partially dissolved solid material. Whatever that is, it's searing hot. Scientists estimate the temperature in this region could be up to 90,032 degrees Fahrenheit, hot enough to melt titanium.